This is the case of a Castigliano theorem. In the Castigliano theorem, we are able to calculate the deflection by the procedure followed here over this in these two cases. What is Castigliano theorem? It is used to calculate the deflection of the complicated structures. Okay. Secondly, it is used to calculate the deflection of the beam which are facing the effect of shearing and bending. Third one is that we can calculate the deflection of the curved beams. That is your crane hooks and springs, we can say, etc. So let us see how we can solve Castigliano theorem for the case of with the uniformly distributed load. So let us see. Whenever you need to calculate, for example, we are having this case in which we need to find the deflection at point C. What we do, that we have taken the value of the load is given to be 60 kilonewton. We need to find out the value of the deflection under this point only. So what we'll do, we'll take a dummy load at this point, that is W. Now, first step, we are having 5 steps to calculate the deflection using Castigliano theorem. The first step is that you just assume the load to be under which point you need to calculate the deflection. Just assume the dummy load, that is W at that point. So now step 1, calculating the value of RA and RB. We know we are having about upper one only point load, that is W. So RA plus RB is equal to W. Secondly, taking the moment about the point B, then RA into the distance, that is 4, RA into 4 is equal to W into 1. We get the value of RA and RB, and we split these values in further equations. Let us now find the value of Mx. Why we are finding the value of Mx? Because we are having the deflection for the case that we need to find the deflection. For this we are having the formula mi by dx dm curly m by curly w into dx. So now we are finding the value of mx, which is to be finding the value of movement at this point, that is Ra into this distance minus dummy load into this distance. So I have taken Ra into x minus w x minus 3. So we sort out this equation and we get this value. So now our second step is to calculate curly m by curly w. We are having the value of mx. Now we just differentiate this value with w. So we get the value, if we differentiate this, we get x by 4 minus x minus 3. W get disappeared from this equation and we get this value of curly m by curly w. Step 4. Now you need to just put the values of Ra and Rb, put the values of mx and dm by dw in the equation of deflection by Castigliano theorem. So now we know that beam has to be split up. It is total of 4 meters. Beam has to be split out into 2 parts, that is 0 to 3 and 3 to 4. Now I have split the beam in 2 parts, 0 to 3, 3 to 4. For 0 to 3 you need not to take the value of dummy load, and from 0 to 4 you have to take all the loads acting on the beam except point B. So now for the case 1, W by 4 into x was the value of Ra into this distance, that is the value of the mx. We have put it out into dm by dw. This was the value of mx for 0 to 3 and this was the value of curly m by curly w. We have put these two values over here. Similarly, from 3 to 4 we have to take whole beam. So multiplying this mx into curly m by curly w, we got this value. Finally, we solve the equation. We are having integral equation. We just get the formula xn, that is in the integral it is xn plus 1 divided by n plus 1. We split the equation of integral into these 2 parts. And finally we got put the value of W is 60 kilonewton because we have assumed that the point load is to be 60 kilonewton and EI is 2.2 meganewton meter square. It is already given in the question, and so the deflection is coming out to be 20.45 mm. Similarly, let us come to the case 2, in which we are having an uniformly distributed beam of simply support. What is happening in this case? There is no point load. We need to calculate the deflection at point at the center of the beam. So we assume that there is a dummy load acting at the center of the beam, which is a value of, say, W is a dummy load, it is 0, but we have to take it in the initial part. Similarly, we'll follow all the 5 steps. First of all, calculating the RA and RB. Second step will be the calculating the value of movement, that is mx at center, mx at this point of the beam, not at the center. That is curly m by curly w, differentiating this equation to find the value of curly m by curly w. Now putting the value of your fourth step, that is calculating the deflection, which is the equation mx by ei curly m by curly w into dx from 0 to L integral. So we put the value of to calculate the deflection, we put mx value, curly m by curly w value in this equation. Now we will split the equation again in 2 parts, 0 to 1.5 and 1.5 to 3. Why we do this? Because we need to calculate the beam, we need to calculate the deflection in the whole beam for which the load is concentrated at the center. So finally, by putting all the values, we got the deflection value of 9.37. EI was given to be 2.25. And in this case, you will not take W as 60 kilonewton because it is not given to you. You will take W equal to 0. You will take W equal to 0 and you will get the value of deflection. So these were the 2 cases of calculating the deflection of the beam using castigliano theorem. One was the simply supported beam with a point load. Second was the simply supported beam with the uniformly distributed load. So in these 2 cases, you have to follow 5 simple steps to calculate the deflection. Just keep one thing in mind: whenever you are trying to put the dummy load on your own, you have to put that value 0 at the end. When you are assuming